Alright guys, welcome back to another video, and today we'll be working part 2 of the January 2011 paper 2 from questions 7 to 11. Questions 1 to 6 were already posted on the channel, so you can just go ahead and check out that video if you haven't seen it as yet. So question 7 starts by saying the diagram below shows the triangle RST and its image R prime, S prime, and T prime after a transformation had taken place. So now if we are observing these two triangles, basically we can see R from R prime is basically 1, 2, 3, 4 centimeters away, which basically we can see it is a lateral inversion taking place. Basically it's like you're looking in a mirror, so there's actually some amount of flip taking place, a reflection, as R is here and then S that was up top is now at the bottom and T is right here. So it seems as if the triangle, the original, the object has flipped to form an image. And if we further look and analyze, we can see that more than likely that means the mirror line would be somewhere right here, where there is 1, 2 centimeter away from the image and 1, 2 centimeter away from the object. So therefore we can say some amount of reflection takes place in the line where y is equal to 2, and that's just from observation before we started even answering the questions. So part 1 says write down the coordinates of R and R prime. So it's basically just looking at the graph and seeing where R and R prime is. And remember, whenever we're writing coordinates, it's always X coordinates first, followed by Y coordinates. So therefore, R is equal to, so R from the X axis, we have 2, and from the Y axis, it is 4. So R is equal to 2, 4. So this is literally just reading off from the graph, and R prime is equal to, this is 2 for the x-axis and 0 for the y-axis, as it is directly on the horizontal line. It is 2 from the x-axis and 0 from the y-axis, and that is our answer for part 1, and we got our 2 marks. So part 2 says describe complete the transformation which maps RST onto triangle R prime, S prime, T prime, and we had discussed some of that up top from just by looking and observing the graph. So I guess we can start by saying triangle RST is mapped onto triangle R prime, S prime, T prime. So triangle R is mapped onto by a reflection in the horizontal axis, or the horizontal axis or horizontal line, where y is equal to 2. Oh, horizontal, let's just say horizontal line where y is equal to 2. So that's one of the first observation that it means. So looking at transformation, clearly from jumpstart, you could see that it was a reflection. So also by observing the vertices of both triangles, we would realize that they are the same perpendicular distance. On opposite and opposite side of the line y equal 2. And both figures are congruent, and the image is laterally inverted, as I'd also stated. The image is laterally inverted, meaning that an image, it's like looking in a mirror and basically seeing yourself. So that is what is taking place with that graph up top. So part 3 now says RST undergoes an enlargement where center is at 0,4 with a scale factor of 3, and it says on your answer sheet, draw the new RST, the image of triangle RST under this particular enlargement. First, we'll subtract the center that they've given us, the 0,4 coordinates, from the object to allow it to go through the center of origin 0, 0, and then we will multiply this by the scale factor that was given. So the matrix of enlargement to the scale factor of 3 would be 3, 0, 0, 3, and then we add back the center that we had originally subtracted, and I've just represented this in a table so that it doesn't take up a lot of space. So the original coordinates for R was 2 and 4. For S, it was 3 and 7, and for T, it was 5 and 5. So we'll go ahead now and subtract the center that is given. So we're doing 2 minus 0 to give us 2, and 4 minus 4 to give us 0. And then I'm going to multiply this by the matrix of enlargement, which is a scale factor of 3. When we do that, what we'll get here is 6, 0, and then we'll add the 6 and 0, and we're adding back the center of enlargement that was given, or the center of rotation rather, and we'll get 6 plus 0 to give us 6, and 4 plus 0 to give us 4, and this represents the new R prime that we are in search for, and we're doing the same procedure for S and T. So it will be 3 minus 0 to give us 3 right here, and 7 minus 4 to give us 3, and then we're performing a multiplication here, so we're multiplying or enlarging this 3, 3 by the scale factor, and what we'll get here is 9 and 9, and now we're adding back the center of rotation, so it is 9 plus 0 to give us 9, and 9 plus 4 to give us 13, and we're doing the same thing for T, so it is 5 minus 0, subtracting the center of rotation to bring it through the rotation of 0, 0. 5 minus 0 is 5, and 5 minus 4 is 1, and then we do the multiplication by the scale factor, and what we'll get here is 15 and 3, and then when we do our addition here, we'll get 15 and 7, and it is now these figures 6, 4, 9, 13, 15 and 7 that will give us our triangle point that will resemble this in this graph. So part B now says, given that the area of triangle RST is 4 square units, calculate the area of triangle of the new triangle that we had just calculated on the graph. So what we know is that we can do this by finding the ratio of the areas of enlargement, and there are 3 ways. So it will be area of the object to area of the image, and basically there are 3 different methods we can use to calculate this. So it can be done by saying the length of the object squared, so length of object squared to length of image squared, which is basically saying object over, so area of the object is equal to object over image. Or we can do this also by saying 1 to the determinant. So that's the determinant of the matrix. Or final method, it can be 1 to k square, where k square is the k scale factor. So what we're going to use is the method of 1 to the determinant. So what we're saying is area of the object to area of the image is equal to 1 to 9, which is 1. So let's say 1 to the determinant that we're looking at. How do we get the determinant? By basically cross multiplying with the diagonals of the transformation matrix. So if I remember before, the transformation matrix was given as 3 from the working that we had done up top, the scale factor. So it is 3, 0, and then 0, 3 basically. So therefore, when we do the cross multiplication of this transformation matrix, what we will get is the determinant being equal to 3 multiplied by 3 to give us 9, and 0 multiplied by 0 to give us 0, and 9 minus 0 is 9. Therefore, area of the, so let's say area of the object to image is equal to 1 to the determinant, which we got as 9, and therefore it is saying that the area of the triangle, the RST was 4 square units. So therefore what we have is that being equal to 4 to x. So we're trying to now solve for x basically. So what we can do here is just to do some cross multiplying. So we have 4 multiplied by 9 and x multiplied by 1. So what we have is 4 multiplied by 9 is equal to x multiplied by 1. And we can now go ahead and solve for x. So 4 multiplied by 9 is 36, and x multiplied by 1 will basically be 1x or x, and our answer for the area is therefore 36. That is one way of working it out, or basically looking under an enlargement, the image increases by the square of the scale factor. So what we're saying is the image, which is what we're trying to find out, increases by the square of the scale factor. So the square of the scale factor multiplied by the area that they're giving us, which is 4. So what we'll have is the area of the image. So area of image is equal to 3 3s 9, 9 multiplied by 4, which is basically what we got there in the end. This is just a longer way, and what you'll get for your final answer is the 36 square meters. I think that's the unit that they're given, square units actually, and that is the area of the new found image. So part C says state 2 geometrical relationship between the triangles RST and the image of RST that was found. So what we know is that triangle RST, which is the object, is similar to triangle R prime, S prime, T prime, and the image is an enlargement of the object. So that's basically, so part C, the image is an enlargement of the object. So therefore, triangle RST is similar to triangle ST. And second, the ratios of the corresponding sides of the image and object are all the same. So the ratios of the corresponding sides of image and the object are all the same. So basically, when you do the work, by dividing the image that was formed by the object, so RS prime divided by RS, and ST prime divided by ST, and RT prime divided by RT, what you'll get is 3, which is the scale factor. And that is it for that part of the question. Question 8 now says an answer sheet is provided for this question. The answer sheet shows a rectangle of area 20 square units and a perimeter 24 units, and says use the information below to complete the table on the answer sheet which shows the length, width, area, and perimeter of rectangles B, C, D, and E. On your answer sheet, draw and label A, rectangle B of 27 square units and perimeter 24 units. So if this original rectangle that was given had 20 square units and a perimeter of 24, and therefore it took up 12 squares basically for each side for the perimeter to be 24. So if now we have 27 square units and a perimeter of 24 units, just by judging, it would mean that we will take up, so let's go for our, so what we know is 3 multiplied by 9 is 27. So more than likely that is what our square will look like. So what we'll have is 1, 2, 3, 4, 5, 6, 7, 8, 9, and down and back across to complete our square, and this is B. And should you do that, so this is 3 multiplied by 9 is 27, and that is the area, and that would be it for our rectangle B. Rectangle C of 32 square units and perimeter 24 units again, and we're required to label and draw this. So now looking at this, it will be 8 and 4. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, and then across to complete our rectangle. And this is C. But now the good thing is the question that follows allows us to, if you are having difficulty with just looking at it and figuring it out, to complete a table which will give us the length and the width of each rectangle. So part 2 says complete the table to show the dimensions of B and C drawn in A above. So therefore you could have even completed this before drawing the table. So what we know is that for the area of a rectangle, it is length multiplied by width, and that will give us 27 for the first equation. So we're doing the one for B, so it will give us 27, and for perimeter, we know that the equation for that is
2 multiplied by the length plus 2 multiplied by the width.
And what we'll get there is 24. So now we're going to divide equation 2 by 2, and what we'll get is
length plus width is equal to 12.
So now using equation 1 and equation 3, we're going to perform the method of substitution, where I'm going to make W be the subject of the formula from equation 3. So what I'll have is W is equal to 12 minus L, and it is this that I'm going to substitute into equation 1 of length multiplied by W, and for W we're now going to put 12 minus L is equal to 27. And it is this now that I'm going to use to solve. So with expanding using the distributive law, so we're going to have L multiplied by 12 to give us 12L minus L squared, and that is equal to 27. Now I'm now going to remove what is on the left hand side to put it on the right hand side. So I'm going to have 0 is equal to L squared minus 12L plus 27, and this now resembles a quadratic formula, quadratic equation that is usually given of ax squared plus bx plus c. So and that is how we're going to solve this equation. So what we know is that first we need to find what our AC figure is, and then it is using this that we're going to decide which two numbers can multiply to give us our AC figure, and at the same time when you add them will give us our B figure, which is in the middle, which in this case is a minus 12. So what we have 0 is equal to, so the two numbers that we're going to use, AC is 27, two numbers that can multiply to give us 27 are -9 and -3. So a negative multiplied by a negative will indeed give us a positive 27, and when you add a -9 and a -3, you will get -12. So we're going to replace now the middle term with these two found numbers that we have. So we'll have is L squared minus 9L minus 3L plus 27, and then we can go ahead and factorize using grouping. So for the first term, what we have is L squared minus 9L. What is common is L, and I'm going to say L into L squared will leave me with L, and L into minus 9L will leave me with minus 9. And now for the second pair terms, what is common is minus 3. So it's the minus 3 into minus 3L will leave me with a positive L, and minus 3 into positive 27 will leave me with a minus 9. And therefore, factorizing again, 0 is equal to L minus 3 and L minus 9. And from here, we can now go ahead and solve for the two possible values of L. So therefore, 0 is equal to L minus 3, or 0 is equal to L minus 9. And when you solve, what you'll get is 3 is equal to L, or 9 is equal to L. So these are the two possible figures. So therefore, what we can do now in our formula of length multiplied by width, which was the area, which gave us 27, we can now basically substitute. So I'm going to use the larger value for L, which is the length, into the formula of length multiplied by width is equal to 27. I'm going to use L to be 9, so it is 9 multiplied by width is equal to 27. And now we can go ahead and solve for for W, and therefore W is equal to 27 divided by 9, and when you do that you will get 3. So therefore L is equal to 9 and W is equal to 3. And when you input those into any one of our formulas from above, L times W, 3 times 9 is 27. So as we said, our length is 9, which is what we drew for this diagram B here, and our width is 3. So that is another way how we could get to know what exactly how to draw the dimensions for that. C now says the area, it says the area is 32 and the perimeter again is 24. So we're using a similar concept. So for C, so length multiplied by width is equal to 32, and 2L plus 2W is equal to 24 again. Once again, we're dividing our equation 2 by 2 to simplify it, and what we'll get is length plus width is equal to 12. So we're dividing straight throughout by the number 2, and then we're going to make W the subject of the formula in order to substitute it into equation 1. So what we'll have is 12 minus L. Again, and it is notice that we're substituting into equation 1, which is L multiplied by W, and we say that W is 12 minus L, and that is equal to 32. Using our distributive, we'll have to expand. We get 12L minus L square is equal to 32, and now solving for L. So we're taking over those two on the left hand side to the right hand side. So what we'll get is 0 is equal to L square minus 12L plus 32. Solving now using quadratic expression. So what we'll have is 0 is equal to, sorry, AC term in this case is 32 and our B term is 12. So we're looking for what two numbers can we multiply to get positive 32, and at the same time when we add them we will get a negative 12. So those two numbers will work out to be a negative 8 and a negative 4. So what we'll have is L square minus 8L minus 4L plus 32. And then now when we factorize, what we'll get is 0 is equal to, so for the first paired term, the common factor is L, and L into L square will leave us with L, and L into minus 8L will leave us with minus 8. And for the second term, what the common factor is minus 4. So what we'll have is minus 4 into minus 4L will leave us with a positive L, and minus 4 into a positive 32 will leave us with a minus 8. And therefore 0 is equal to L minus 4 and L minus 8. And therefore, from looking at this and from how we worked it before, we can already see what the two possible values of L are when we equate both brackets to 0. So L minus 4 equals 0 and L minus 8 equals 0. Our values will come back with L being positive 4 and L being a positive 8. So we're going to choose the larger of the two numbers to be our length, and now substituting that into the original formula of length multiplied by width is equal to 32. What we are going to have is the length we said will take us 8, so it will be 8 multiplied by width is equal to 32, and solve now for W. So it is, the width is equal to 32 divided by 8, which will be equal to 4. So therefore our length is 8 and our width is 4. And that is what you'll see if you remember, we drew in the diagram above. So our length was 8 and our width was 4. So we have basically completed B and C for this portion of the table, and we have D and E remaining, which comes in another question. So it says rectangle D has a perimeter of 24 with length L and W and width W. If the area of the rectangle D is to be as large as possible, determine the values of L and W. So what we have is B, and what we know is that length times width is equal to area. This time around we don't have the area, and from perimeter we know that
2L plus 2W is equal to 24. So that's 2 times the length plus 2 times the width is equal to 24.
Therefore, solving for W is equal to 12. Sorry, this should be 2L plus 2W is equal to 24, and L plus W is equal to 12. So let me see up top what I was, okay, so yeah. So it should be plus. So it is, W is equal to 12 minus L. And we can now substitute this into our first equation. So what we'll have is length multiplied by width, which is 12 minus L, is equal to area, because we don't have the area in this case. And when we expand the brackets, we get 12L minus L squared is equal to A, which is our area. So now we're going to do the same thing. So we have 12 minus L squared is equal to our area. So what we're saying is, if A is equal to 0, in order to sketch a quadratic graph where L is 12 or L is 0. So that's the only way this can be true. So if A is equal to 0, that's what we're going to do in order to sketch a quadratic graph. So therefore the graph of A versus L, which is the area versus the length, is a quadratic as a maximum point which cuts the horizontal axis at 0 and 12. So those are the 2 points, and is more precisely described as a parabola. So therefore the axis of symmetry, which will help in giving us the length, this occurs at, it will be length is equal to negative, so let's give the formula first. It is minus B, and that is divided by 2 multiplied by A. So when you do that, you will see minus negative 12 divided by 2 multiplied by A, and from our equation, A is 1. As a matter of fact, let me put that in. So for those who are wondering, so after we have the 12L minus L squared is equal to A, when you write that as a quadratic, you'll get 0 is equal to L squared minus 12L plus A, whatever that area would have been. So now we're looking at the L versus L square versus A, and we're trying to calculate what the axis of symmetry is, which gives us L. And remember, from quadratic formula, it is ax squared plus bx plus c. So whatever number that is in front of the squared term is or A, and in front of this L squared, what is there is 1. So that's how we get the 1 here for the 2 multiplied by A. And our B term right here, which is minus B, is equal to what is on the X, which in this case is a minus 12. And that is how we get the figures right here. So this will be equal to 6. And this is the maximum point. So the maximum point occurs when L is equal. So that's on the x-axis, the length. So maximum point occurs, so that turning point on the parabola, maximum point occurs when x is equal to 6. So if I can draw, so remember from a parabola it will look something like this. Well, not like this, but you get the idea. So it is, so what you're saying is this maximum point here occurs when on the x-axis it is 6 basically. And remember, our x-axis was the length and the y-axis is our area. So we just found out what the length is, and we had calculated up top our transpose our formula of W is equal to 12L. So we can now put that into that equation to get what W will be. You can put it into any equation, it basically still solve once it is able to. So what we have is W is equal to 12 minus L. We now know what the value for L is, so W is equal to 12 minus 6, and therefore W is also equal to 6. So length is 6, W is 6, which is the width, and therefore area is equal to length multiplied by width, and we just found our length and our width, so that is equal to 6 multiplied by 6, which is equal to 36. Our area for when the triangle is the square, the rectangle is as large as possible. So rectangle D, so to be as large as possible, it will be when the length is 6 and the area is also 6. So length is 6, width is 6, area is 36, and our perimeter remains at 24. So we basically get a square in that instance. So part C now says rectangle E has a perimeter of 36 centimeter, length L and width W. If the area of the rectangle E is to be as large as possible, determine the values of L and W, and in the table write the values of L and W and the area of the rectangle E. So it will be a similar procedure like what we just did for part B. So part C. So what we'll have is length multiply by width, which gives us our area for equation 1. Equation 2 will have 2 length plus 2 width is equal to the perimeter, and I think they gave us the perimeter as being 36, and they're asking us to find length, width, and area. So let us see if I'm correct. So they're asking us, they gave us a perimeter of 36 and they want us to find the length and the width. And again, the area they're saying the rectangle is to be as large as possible. So it will be a similar procedure. So first, we're going to get W being the same for both equations. I'm going to divide my equation 2 by 2, and I'll get length plus width is equal to 18, and that will be my equation 3. And now solving for W is equal to 18 minus L in order I can put it into my equation 1. So it will be, I'm calling this equation 4. So now what we'll have is substituting W is equal to 18 minus L into equation 1. What I'll have is length multiplied by W, and W is 18 minus L, and that is equal to area. And therefore, when you work out that by distributive law, you get 18L minus L squared is equal to the area. And when you do that working, you will have 0 is equal to L squared, writing it in the form of a quadratic, L squared minus 18L plus A, as that is what we had done before. So therefore, if A is equal to 0, then L is 18 and 0. So therefore, on a parabola, on a graph, those would be the possible numbers for our L values. So therefore, L is, say if you're doing a sketch of your parabola or a graph, L would be equal to 18 and L equal to 0. So that is when our area is 0. So when you work out that, that's what you'll get. So on a quadratic, what we'll get is, so if we're looking at a quadratic, what you'll get is a quadratic graph. You'll get this, and you'll get L cutting at the point 0, so passing through the origin and also at 18. So those would be the two. So it probably looks something like, not like that, something like this, where it is passing through those 2 points. So remember the formula up top. So it is length is equal to minus B, which in this case would be minus 18, and all of that is divided by 2 multiplied by A. So what we'll have is 2, and A again is 1. So therefore, when you work that out, what you will get is your length being 9. And when we get now what length is, remember from our formula, we have W was equal to 18 minus L, and we know what L is now, so we can put that in. So W is equal to 18 minus 9, and when you do that, W is equal to 9. So once again, the axis of symmetry takes place at when length is equal to 9 on the x-axis, and therefore we can now calculate our area. So therefore, area, which is equal to length multiplied by width, is 9 multiplied by 9, and when you get that, you will get 81 being your area. So for a perimeter of 36, our area will be 81, and our length and width would be 9 and 9 respectively. And that is it for question 8. So part 9 now says, question 9 says the functions f of x and g of x are defined as follows. F of x is 2x minus 7 over x, and g of x is the square root of x plus 3. And it says evaluate f of 5. So f of 5. And if we're putting that into the f of x, which is 2x minus 7, and all of that is divided by x, what you'll get is everywhere we see x, we will replace it with 5. So it is 2 multiplied by 5 minus 7, and all of that is divided by 5. And 2 multiplied by 5 is 10, so it is 10 minus 7, and that is divided by 5, and 10 minus 7 is 3, so it is 3 over 5. So f of 5, when you work that out, you'll get that being 3 over 5, and that is our 1 mark there. Part 2 now says write expressions in x of f inverse of x. F of x is the same as y, so therefore you're saying y is equal to the equation that is given, and then you're substituting your y's for your x and x for your y's, and then solving for y all over again. So for f inverse of x, so basically what we have is y is equal to 2x minus 7 divided by x. And what I'm saying is, we're going to substitute the x's for y's and the y's for x. So what we'll get is x is equal to 2y minus 7, and all of that is divided by y. And now basically we're going to solve for y. So what we'll have is xy is equal to 2y minus 7. So the y was dividing here, so when it comes up it will be multiplying. So basically we're multiplying both sides by y. So we'll have xy is equal to 2y minus 7. Now we're taking our 2y from the right hand side of the equation to the left hand side. It was a positive y there, so when it comes across it will become a negative. So what we'll have is xy minus 2y is equal to minus 7. And now basically we can factorize this side of the equation. So what is common is y. So y, and then y into xy will leave us with x, and y into minus 2y will leave us with minus 2 is equal to negative 7. And now making y the subject of the formula, it is y is equal to negative 7 divided by x minus 2, and that is our answer. So it is negative 7 divided by x minus 2. So therefore f inverse of x is equal to negative 7 divided by x minus 2, and that is our answer. And this is possible where x is not equal to 2, so therefore x cannot be equal to 2 for this to be possible. B now had asked us it says g f of x. So basically what we're going to do is wherever in G we see x, we will replace it. Wherever in G we see x, we will replace it with f of x, basically, which is 2x minus 7 over x. And that is how we will solve part B of that question. So part B, so g f of x, so it's composite. So what we'll have is g f of x is equal to the square root of x plus 3, and we say wherever we see x, we'll replace it with what was there for f of x. So that will be 2x minus 7, and all of that is divided by, so it is 2x minus 7, and all of that is divided by x plus 3. And that is how it will look. And then we can now go ahead and basically work our equation. So g f of x, so this is basically two fractions, and when you look at it, our LCM will work out to be x. So therefore what it will be is x into x goes one time. So what we have is 1 multiplied by 2x minus 7, which will give us back 2x minus 7. And then we have 1 into x goes x time, and x multiplied by 3 will give us 3x right here. And that is it basically. So now in rewriting, so that is g of x is equal to the square root of 2x plus 3x minus 7, and that is divided by x, and that is it. So now when we add, what we'll get is g f of x is equal to the square root 3 plus x will give us 5x. It is 5x minus 7, and that is divided by x. And basically this can be just simplified once more to give us g f of x is equal to the square root of 5 minus 7 over x. Basically, so it is 5 minus 7 over x. Ignore the brackets that are in the middle, so it is the square root of 5 minus 7 over x, and that being our final answer. So now part B says express the quadratic function 1 minus 6 squared minus x squared in the form of k minus a open bracket x plus h squared, where a, h, and k are constants. So what we're going to first do is to work out our bracket here of x plus h. That will help us in writing it to get in exactly what the numbers from 1 minus 6x minus x squared are. So what we'll have is x plus h square, which I'm just going to write it out. It's x plus h square, and we're basically working this out in its entirety. So it will become x multiplied by x to give us x square, and x multiplied by h to give us xh, and then h multiplied by x to give us, again, I'm going to write it as xh, and h multiplied by h to give us h square. And then what we'll have is x square plus 2xh plus h square. And I'm now going to put this back into the formula that was given of k minus a open bracket x plus h square. So therefore, that will result in it being written as k minus a, then in bracket x square plus 2xh plus h square. So now what we'll do is multiply a by each term in the bracket. So what we'll have is k, and then minus a multiplied by ax squared, we'll have minus a x squared, and now minus a multiplied by 2xh, we'll have a minus 2 hxa or xha minus ah squared. So now, actually, let us write this as a x squared as a hx as the format of the formula. And now we're just going to rewrite this in the format of the formula. So we'll have is a x squared being the first term, the x squared portion come first, then followed by the x, where we have minus 2ahx plus k minus ah squared. And it is this now that we're going to line up the 1 minus 6x minus x squared under. So it is 1 minus 6x minus x squared. So if we should rewrite that, it will be in the same format. It will be minus x squared minus 6x plus 1. So therefore, what we can see is that negative a here is equal to negative 1. So remember, it is showing that a right there is negative, so it's negative a is equal to negative 1. We know that we cannot allow our letters or our variables to remain as a negative number. So what we'll do is multiply throughout, divide throughout by negative 1. Sorry, so it will be a is equal to a positive 1. So now from that, we can now go ahead and solve other parts of the, so you can see it is a negative e right here. So now we can go ahead now and solve. So what we have is minus 2ah is equal to negative 6x. So the x portion, so the negative 6 is equal to the minus 2ah, and we can now go ahead and solve. So therefore we have minus 2ah is equal to negative 6. We can now go ahead and solve. So start by substituting. So minus 2 multiplied by 1, which is the value for a, which we just found out, multiplied by h is equal to negative 6. So now what we have is minus 2. So 2 times 1 is 2h is equal to negative 6. And therefore h is equal to negative 6 divided by negative 2. And that will result in a positive 3. So therefore the value for h is a positive 3. Now in the end, this part of k minus ah squared is equal to 1. So k minus ah squared is equal to 1. And now we can go ahead and solve for that part. So what we have is k minus ah squared is equal to 1. We know what the value for a is, we know what the value for h is, so we can go ahead and solve what the value for k is. So k minus a is 1 and h is 3, so it is 3 squared is equal to 1. So it is k minus 1 and 3 squared is 9 is equal to 1, and therefore what we have is k minus 919 is equal to 1, and therefore k is equal to 1 plus 9. So the 9 was subtracting on the left hand side. When it comes across, it will be adding, so therefore k is equal to 10. So now we can go ahead and rewrite our equation in the format that the question asks us. So it said to write the quadratic function in the form of k minus x plus h squared, and we just found out what all three constants are. So therefore, now in rewriting it, so our answer is 10, which is our k, minus a was on the outside and a is 1, and in bracket we have x plus h, and we know what the value for h is, which is 3, and all of that is squared. So that is the original quadratic function that was given, written in the format that they required. So part 3, determine the roots of 1 minus 6x minus x squared is equal to 0, giving your answers to 2 decimal places. So that formula, using the quadratic formula, what we have is x is equal to minus b plus or minus square root of b squared minus 4ac, and now all of that is divided by 2a, and that is the quadratic formula. So now it is this now that we're going to basically populate from that up above. So what we know is that from the equation that is given of 1 minus 6x minus x squared being equal to 0, when we rewrite that, what we get is minus x squared minus 6x plus 1. And now if we look at that, what we know is that a is equal to -1, b is equal to -6, and c is equal to 1. So we can now substitute those values into this equation. So what we know is that b is equal to a -6, and this already should be a minus b, so we know we'll put back our minus sign there, plus or minus b squared, which is -6 squared minus 4ac, and a is -1 and c is 1, and this is divided by 2 multiplied by -1, which is a. And it is now this that we're going to continue work on until we arrive at our final answer. So what we know is that a negative times a negative will leave us with a positive number here. So what we'll have is a positive 6, and negative 6 squared will leave us with positive 36, and 1 multiplied by 1 will leave us with a negative 1, and negative 4 multiplied by a negative 1 will leave us with a positive 4 here. So it is negative 1 multiplied by negative 1 leave us with negative 1, and negative 4 multiplied by negative 1 will leave us with a positive 4 there, and 2 multiplied by negative 1 will leave us with a negative 2 here. And now basically when we come down here under the square root sign, 36 plus 4 will leave us with 40. So what we have, x is equal to plus or minus the square root of 40 divided by negative 2, and it is this that we're now going to work out. So what we'll have is one portion with the plus sign and one with the negative sign. So therefore x is equal to 6 plus the square root of 40 over 2, or x is equal to, so x is equal to 6 plus the square root of 40 over negative 2. I'll just work this part first. So what we'll get is, when you work that and put that in your calculator, you'll get x being equal to minus 6.162, and I think it says we should write it to 2 decimal place, or is it 2 decimal place. So therefore x is equal to minus 6.16, or x is equal to 6 minus the square root of 40 over negative 2, and therefore when you work that, x will be equal to 0.162, and writing it to 2 decimal place, x is equal to 0.16, and those are our possible answers when answering part 3, which says determine the roots of 1.6x minus x squared equals 0, giving your answers to 2 decimal place. So question 10 now says the diagram below, not drawn to scale, shows a circle with center. SGH is a tangent to the circle where angle FOG is equal to 118 and angle DGS is 65 degrees. And it says calculate, given reasons for each step of your answer, the measure of OGF. So it is OGF. So OGF. So what we know is that OGF, this triangle, is an isosceles triangle. So therefore 2 sides are of equal length and will therefore have 2 equal angles. So therefore triangle OGF, so we say it is an isosceles triangle, so OGF is therefore equal to, and remember the sum of angles within a triangle is equal to 180 degrees, so it is 180 degrees minus 118 degrees, so therefore triangle this should be angle OGF. So therefore angle OGF is equal to 62. So therefore the 2 remaining sides will give us a sum of 62 degrees. But remember we said that since it's an isosceles triangle, the 2 sides are of equal length and will have the same equal angle. So therefore we can just go ahead and divide 62 by 2. So it will be 62 degrees divided by 2 will give us 31 degrees. And therefore angle OGF is equal to 31 degrees. And part 3 now says Also, if we're given reasons, so we know that it's an isosceles triangle, two sides are therefore of equal length and will have equal angle. And we know that the sum of an angle in a triangle is 180 degrees, so that's how we subtract 180 in the angle that was already given from 180. And then when we get 62 degrees, we divide by 2 because, as we stated before, it is an isosceles triangle. So therefore, we'll have 2 equal angle, and that's how we get 31 degrees. Part 2 now says measure angle DEF. So angle OGS, if you can see the basically the radius from O to G, it cuts with or meets with this tangent at a 90 degrees. So the angle made by the tangent GS to a circle and with the radius OG at the point of contact is equal to 90 degrees. So right here is a 90 degrees angle was formed. So right here, a 90 degrees angle was formed. So therefore, if this is 90 degrees and we already have 65 degrees out of the 90 degrees, we can now calculate what this small portion right here is. So that will be 90 degrees minus 65 degrees is equal to 25 degrees for that small portion. And now angle DGF, which is DGF, we can calculate that. So we now know that right here is 25 degrees. Right in here, which we calculated before where G is, was 31 degrees. So angle DGF is equal to 25 degrees plus 31 degrees, which will give us 56 degrees. So now that is right here. So this entire angle here is equal to 56 degrees. So now we're looking at now angle DEF, which they required us to calculate, which is angle DEF. All we need to do is to subtract 180 degrees minus 56 and we get 124, because the opposite angle of a cyclic quadrilateral DFG are supplementary. And that is the reason for doing that right there. So what we're saying is angle DEF is equal to 180 degrees minus 56 degrees, which will give us 124 degrees. And what we're saying is the opposite angle of a cyclic quadrilateral are supplementary. And that is your answer, 124 degrees, with the reasons that are both written, and that was explained while typing. So part B now says J, K, and L are 3 seaports. A ship began its journey at J, sailed to K, then to L, and returned to J. The bearing of K from J is 54 degrees and L is due east at K. And it says JK is 122 kilometers and KL is 60 kilometers. So draw a clearly labeled diagram to represent the information shown on the diagram. Show on the diagram the north-south direction, the bearing 54 degrees, and the distance is 122 kilometers and 60 kilometers. So it is saying JKL are 3 C, portion, a ship began its journey at J. So what you're going to have is our beautifully drawn port right here. So this is our ship, and it is in water. So this is our ship. So I'm going to call this point right here J. And it says J began its journey. J sailed to K, and it says the bearing from K from J is 54 degrees. So I'm assuming 0 and then 54 degrees. So right here is 54 degrees. So it is saying this is one of our requirements. So I answer part B. It says the bearing of K from J. So the bearing of K from J is 54 degrees. And then it says it sailed from K to L, and L is due east of K. So going in the east direction. So this is K, which is 54 degrees from J. This now is L, which is due east, and we can basically connect or triangle right here. So what we know is that additional information, J to K is 122 kilometers and K to L is 60 kilometers. And the requirements label the north and south directions on each point. What we have is, so this is basically north, this is east, this is south, same thing right here, this is west. So I'm using this west for that side over there as well, and that east for this side. This is north and this is south, and for right here we have north, we have east, we have south, and we have west. So we have fulfilled all three criteria that they asked for there. So part 2 says calculate A, the measure of angle JKL. So JKL, so we're now looking at basically the entire angle right here. So what we know is that right here from looks is 90 degrees. So this portion right here forms a 90 degrees angle. So we have part of it already, which is 90. So we now need to find out what is the angle right here. But remember, we know what the angle right here is, which is 54 degrees, and these are basically alternate angles, and alternate angles are equal. So therefore what it will be is angle JKL is equal to the 90 degrees that is already there plus the 54 degrees, which is alternate, and that will give us 144 degrees. And that is our answer for part A. Part B now says the distance JL. So the distance JL. So this now we'll be using the cosine rule to solve this. So what we'll have is a square is equal to b square plus c square. So we have an angle, so we know that we can go ahead and use it, minus 2bc cos the angle, longer portion to be our a square, and our b square we're using it. So we have a square is equal to b square, which we're using as 122 square, plus c, which, so it's 122 square plus c, which is 60 square, minus 2, and b is 122 multiplied by 60, and that is being multiplied by cos the angle, which is 144 degrees. So a square is equal to, when you do 122 square plus 60 square, what you'll get is 18,484 minus, when you do 2 multiplied by 122 multiplied by 60 multiplied by cos 144, what you'll get is negative 11,844.0088. So therefore, a square is equal to 30,692.0088. And now basically what we're saying is a is equal to the square root of that, which is 3692.0088. And what you get is a being 175.19, and that is our answer for the distance JL. So JL, the distance, will be 175.19 kilometers. Part C now says calculate the bearing of J from L. So we're calculating the bearing. So this is L, the bearing of J from L. So the bearing of J from L, what we'll use here is the sine rule, which is basically doing A over sine A and B over sine B. So what we'll get here is 122 over sine angle calling a sine A, which is sine angle, is equal to 175.19, which we just found, over sine 144. And when we do that cross multiplying, what we'll get is the sine angle being equal 122 multiplied by sine 144, and all of that is divided by 175.19. And when you do that working, you will have angle, which is the angle from what they asked us, which is J from L. You get the angle to be 24.162. So you have 122 multiplied by sine 144, and that will give us 71.7098 divided by 175.19, and you'll get 0.0. So let's just drop that in. So when you do that full calculation up there, what you'll get is sine A is equal to 0.409325 or 326. And when you do inverse sine for that, then that is where you get the 24.16 to be your answer. And now question 11. it says under matrix transformation, M is equal to those points. The points V and W are mapped onto V prime and W prime such that V3, 5 is mapped onto 5, negative 3, and 7, 2 is mapped onto 2, negative 7. So basically it says determine the values of A, B, C, and D. So basically we're going to use using the matrices to solve for this. So what we have is A, B, C, and D. And this is being multiplied by what we have here is 3 and 5 from V, and that is equal to 5, negative 3. So now, should we do our multiplication, what we'll have is row 1 by column 1, and that will give us row 1, which is AB, by column 1, which is 3 and 5. So what we'll have is 3 multiplied by A plus 5 multiplied by B. So 3 multiplied by A, 5 multiplied by B, and that will give us 5. Now we have row 2 multiplied by column 1. What we have is CD multiplied by 3 and 5. So what we have is 3C plus 5D is equal to negative 3. And so let us call this equation 1. This is equation 2. And it is a similar concept for those coordinates 4D, which is 7 and 2. So what we'll basically have is 7A. So if you're replacing the 3 and 5 with 7 and 2 on the left hand side and 2 and negative 7 on the right hand side, so what you'll get is 7A plus 2B is equal to 2, and that is equation 3. And then we'll have 7C plus 2D is equal to negative 7, and this is equation 4. This is equation 3. And it is from these now that I'm going to solve. So taking equation 1 and equation 3, so what we'll have is 3A plus 5B is equal to 5, and 7A, as they have the similar terms, similar variables, so 7A plus 2B is equal to 2. Now writing it in the form of a matrix, what we'll have is in the first bracket, what we will have is 3, 5, this will be 2, and this will be 7, and this is being multiplied by the letters which are basically the same, which is A and B. And that is equal to the 5 and 2. So now what we'll do is therefore make AB, the letters on one side and all the numbers on the other side. So what we'll have is AB is equal to is equal to 3, 7, 2, 5, and this is multiplied, so the inverse of that. So basically you'll see how we work that out in the end, and this is 5 and 2. So now what we'll need to do is to first find the inverse of this, which is basically doing the which is basically finding the determinant and then switching the main cross diagonal and then changing the signs on the other diagonal. So what this will work out to be is AB is equal to the determinant, which is 1 divided by, so it is 2 times 3, which is 6, so it is 6 minus 7 times 5 is 35, and then back in bracket what we will have is, so we're saying we're switching the main diagonal, so this will become 3 and this will become 2, and then changing the signs on the other diagonal, so it becomes minus 7 minus 5, and that is still multiplied by this matrix of 5 and 2, and this is now what we're going to work out. So 1 divided by 6 minus 35 will leave me with a negative 29, and now from our bracket, from our matrices, what we'll have is row 1 times column 1, which is 2 times 5 is 10, and then minus 5 times 2 will give me a minus 10, and from the other one it is row 2 times column 1, which is minus 7 times 5 will give me a minus 35, and 3 times 2 will give me a positive 6. So when we work that out, what we will get is AB is equal to 1 over minus 29, and then when we work out in bracket, what we will have is 10 minus 10 is 0, and minus 35 plus 6 will leave me with a minus 29. And therefore, when I now do the multiplication of 1 over 29 times do 1 over minus 29 times 0 over times 0 and minus 29, what we'll get for the answers is 0 and 1. So what we'll have is 0 and 1. So therefore, from this, we can now infer what the values of A and B is. So therefore, A is equal to 0 and B is equal to 1. And this is the similar process that we will take to do C and D. So now we're going to be taking equation 2 and equation 4. So what we'll have is, so equation 2 and equation 4, so what I have is 3c plus 5d is equal to -3, and 7c plus 2d is equal to -7, going through the same procedure again. So now what we will have is the numbers, which is 3 and 7 and 5 and 2, multiplied by the letters which is common in each, which will be C and D. And then we have our -3 and our -7. So now we have our C and D on the left hand side, and we have brought over the first matrix, which will become the inverse, which will be 3, 7, 5, and 2. And when we're finding the inverse, we know we'll go and also find the determinant. So we have a -3 here, -7. So now what we'll have is C, D, and that is equal to the determinant right here, over 2 times 3 is 6, minus 5 times 7 is 35. So that's the determinant right there that we found. And we have now in brackets, we switch the main diagonal. So we'll have 2 here and 3 at the lower part, and then change the sign on the other diagonal. So we'll have -5 and -7 here. And we put back our -3, -7. So now what we have here is our same CD carrying down, and now this becomes, for the determinant, it is 1 over 6 minus 35 is -29, and in bracket we'll have 2 row 1 times column 1, so it is 2 multiplied by 3 to give us -6, minus 5 times -7 will give us a +35, and in the lower area it is -7 times -3 to give us 21, and 3 multiplied by -7 to give us a -21. So right here what we'll have is C and D, and for the determinant portion it is 1 over -29, and -6 plus 35 will give us a +29, and 21 minus 21 will leave us with a 0. And then when we do that working out, what we will have remaining is 1, 0. So this should be -1 and 0. And that is, so therefore C is equal to -1 and D is equal to 0. So what we know now, we can substitute for what we have where they wanted us to find A, B, C, and D. And that will be A, B, C, and D is equal to 0, 1, and -1, 0, respectively. So part 2 says state the coordinates of Z such that Z, which is xy, is mapped onto Z prime, which is 5, 1, and the transformation of M. And we know what the transformation of M1, which is M, which is 0, 1, -1, 0, which xy is equal to 5, 1. So if we do this row 1 by column 1, so what we'll have is 0 multiplied by x to give us 0x, plus 1 multiplied by y to give us 1y, and then negative 1 multiplied by x to give us negative 1x, plus 0 multiplied by y to give us 0y. And that is what we'll get. So now we can go ahead and solve for x and y respectively, as 0x plus y will give us 1y right there. So if we're just taking this, so 0x plus 1y right here will just leave us with 1y being our solution, and minus 1x plus 0y will leave us with minus 1x right here is equal to 5 and 1. Y is equal to 5, and minus 1x is, or minus x is equal to 1. So both are 2 by 1 matrices and are equal. So equating corresponding entries, we obtain y is equal to 5. So let's just write the note. So both are 2 by 1, 2 by 1 matrices and are equal. So therefore, equating the corresponding entries, what we'll have is y. What we'll have is y is equal to 5 and minus x is equal to 1. And therefore, in further going, we know we cannot allow our variable to negative. So what we'll have is x is equal to 1 is equal to negative 1 by dividing both sides by negative 1. So hence x is negative 1 and y is 5. So zxy is equal to negative 1 and 5, which gave us the z prime of 5 and 1 being our answer. So part 3 now says, describe fully the geometric transformation of M. So the transformation mix of what we found up top, which was this. So the transformation mix represents a rotation of 90 degrees clockwise about the origin. And that is it. So part 3, the transformation mix, which we worked out there, represents a rotation of 90 degrees clockwise about the origin O, and that is the answer there. So B now says vectors which are OP and OR are position vectors which represents the origin O, and P is the point 2, 7 and PR the point 4, -3. So write in the form AB the vectors OP. So since O is the center, the origin, what we now know is that OP therefore will be equal to the point P that was given. So therefore P is equal to OP, and therefore that will be equal to 2, 7. So it is 2, 7. Now for B says write in the form the vectors OR. So what we know is that PO plus OR is equal to PR. So this is from multiplying. So once the terms in the middle are the same, we know that the end is always those on the outside, which is P and R. So PO plus OR should give us PR. So we know what OP is. So PO is just the flip of that. So the signs are basically changing on the vectors of OP. So what we will have is -2, because we just find OP, -2, -7, so it's just the flip of it, plus OR, which we're calling A and B, and that is equal to PR, which the question gave us as 4, -3. And now we're just going to solve for AB. So what we have is -2 plus A is equal to 4. So what we have is -2 plus A is equal to 4. So we're just going to go ahead and solve for A. So therefore A is equal to 4 plus 2, as it 2 was negative, so when it comes across it is positive. So A is equal to 6. And therefore for B, it will be -7 plus B is equal to -3. So what we have is B is equal to -3 plus 7, and therefore B is equal to 4. So therefore OR is written in the form of 6, 4, and that is our answer for OR. Part 2 notes a point S as coordinates 14, -2. Find RS. So what you know is that OR plus RS is equal to OS, basically. So we're finding the point. Let's say a point S as coordinates 14, -2. So we know that OS will be equal to S, which will be 14 and -2. We know what OR is, which is 6 and 4, and we're trying to find now RS. So what that will give us is OR is 6 and 4, which we just found above, and that plus RS, which let us write it in, or let us say R and S, and that is equal to the point S, which is the same as OS, which is 14, because remember they're coming from the origin, which is 14, -2. So we can go ahead and now solve. So it will be 6 plus R is equal to 14. So therefore R is equal to 14 minus 6, and therefore R is equal to 8. And then we can go ahead now and solve for S, which is 4 plus S. 4 plus S is equal to -2, and therefore S is equal to -2 minus 4, and S is equal to -6. So therefore answers for R and S is equal to 8, -6, and RS is 8, -6. So part B now says show that P, R, and S are collinear. And what collinear mean is that 3 or more points are said to be collinear if they lie on the same point. So let us try and use a graph to show exactly what that will look like. So the points that are given are P, R, and S, and they had told us P was 2 and 7. We had worked out R, which is 6 and 4, and they had given us S, which is 14 and -2. When that is plotted on our graph, this is the straight line that we will get. And as I stated before, let us see if this can show it, that collinear is when 3 or more points are said to be collinear if they lie on the same point. So as you can see, line on the same point are these 3 lines. So one straight line can go through all 3 points. So that is it when it is said to be collinear. So that is how you will get the straight line. So because they are both going in the same direction. So P to R. So let's say R was right here. This is P, and this is S. So what we're saying is that PR is for -3 and RS is 8, -6. So basically, if we had factored out 2 from this, what we'll have is 2, and 2 into 8 goes 4 times, 2 into -6 goes -3 times, which is the same thing as this right up here. So all we're saying is that there's just a scalar multiple with it being 2. So all we're saying is that PR was multiplied by 2 to give us the line or the vector of RS. So therefore RS is parallel to PR, as R is a common point. So P and R must lie on the same line with PS, and therefore PR and S are collinear. And as we stated, collinear is when 3 or more points are said to be collinear if they lie on the same point. So what you'll have is this, they're going in this direction. So thank you for watching, thank you for listening, and we will see you next time.